Hello, today we're going to discuss a new way to look at the data. Similarities between groups of people are large and important, by Hanel, Maio, and Manstead. It was published in the April 2019 issue of the Journal of Personality and Social Psychology. If you'd like to read the article for yourself, check the description down below for a citation and link. In psychology and in general, we often look at the differences between people. For example, how do conservatives and liberals differ? Or why do some develop mental illness when others with the same background do not? However, differences aren't the only way we can examine people. It can also be interesting and meaningful to study how people who are different in certain capacities are similar in others. If you're not particularly familiar with these types of studies, it's because similarity-based inquiries are understudied and underpublished. Over 90% of psychology journal articles examine differences, and studies that fail to find significant differences are often relegated to the literal or figurative file drawers. And when we present our findings, we often use figures and graphs that highlight differences. For example, we use bar graphs with restricted y-axes to highlight the 0.3 mean difference in variables that range from 1 to 7. In a statistical sense, typically we are interested in mean differences and thus have measures that reflect that understanding. We tend to assume that the greater the mean difference, the more dissimilar our groups are. However, just because the means of the two groups are quite distinct, it doesn't necessarily mean that the groups don't have a fair bit of overlap. If we look at this graph, we see that there is a lot of overlap in how much Yemenis and Americans trust science. Despite there being a decently sized difference between the two means, 80% of the responses were shared between the two populations. In other words, 80% of Americans and Yemenis agree on how much they trust science. It just happens to be that more Yemenis really trust science than Americans do. Statistically, we tend to use effect sizes that reflect how different our group means are. When we compare two groups, we often use a measure called Cohen's d, which signifies how different our group means are in proportion to how much pooled variability those groups have. That d can actually be transformed into a new measure called overlap coefficient, which is exactly what it sounds like. It represents the percent overlap of two groups. Here we see that even relatively large effect sizes translate to sizable overlap coefficients. To make our lives easier down the road, from now on we're just going to multiply that overlap coefficient by 100 to create what the authors call percentage of common responses. However, the overlap coefficient is limited in that it is a parametric measure. In other words, it relies on the validity of certain assumptions like normality of scores. Thus, the authors developed a non-parametric equivalent, which they call the percentage of common scores. In other words, the PCS can be used more broadly since it relies on fewer assumptions. Percentage of common scores is a measure that represents the proportion of the two groups that share the same scores. There's a lot more to it than that, so if you're interested in all the nitty-gritty, check out the paper itself and the supplemental materials for all that stuff. However, there is one more thing to consider when examining similarity. Effect sizes can be quite large for small differences if the examined populations don't vary all that much. As such, it is useful to have another measure that isn't reliant on the population variance. To this end, the authors proposed the use of absolute effect, which signifies how far apart the medians are in comparison to the maximum they could be different. So, if two groups of scores differ by 1.5 on a 9-point Likert scale, the absolute effect would be 17%. In the conclusion to the stats section of this paper, Hanel et al. Proposed the following rule of thumb for determining if two groups are more alike than they are different, or vice versa. If percent of common responses is less than 50 and the absolute effect is more than 50, then the groups are more different than they are alike. Conversely, if PCR is greater than 50 and AE is less than 50, the groups are more similar than they are different. And if both are less than 50 or both are more than 50, the data is inconclusive as to their similarity or difference. So what are the implications of reporting similarity as well as differences in our research? Well, the authors argue that in doing so we can more accurately reflect the nature of our data and might improve how our readers, including lay people, think about our findings. For example, if we return to the World Value Survey results, we could say that Libyans trust science a lot more than Indians, but that would leave out the fact that all the countries surveyed trust in science quite a bit. Now, on to Study 1. This was largely a trial run of the various measures of similarity using the most recent World Value Survey. For predictor variables, they used gender, age, education, income, country of residence, and religion. For outcome variables, they used 10 value types measured using the short version of the portrait value questionnaire, as well as 12 other items selected based on interest and previous work. Because we've got 5 studies to get through, and this one really is just a proof of concept for the proposed methodology, we're only going to hit a few high points here. Countries were less similar than any other category, but still the average percent of common responses was 84. Here we see how countries varied in their trust in science, and overall trust in science was quite high across the board. And in this chart, we see that even when comparing the richest and poorest cohorts, 87% of them shared the same political attitudes. At this point, the authors have established that people can be very similar across a number of dimensions, and they've created a methodology for expressing that similarity. They next wanted to examine the possible consequences of reporting data in the typical manner compared to their proposed method. For Study 2, the authors showed participants either diagrams of overlapping normal distributions, bar graphs with confidence interval error bars, or diagrams of overlapping histograms. Each participant viewed 9 different figures ranging in difference between the two groups. The data was simulated from a normal distribution with a standard deviation of 0.8 and a grand mean of 3. After each figure, the participants were then asked how similar the two groups were on a sliding scale from 0, very different, to 100, very similar. Participants also rated how comprehensible the figure was on a 5-point interval scale, from 1, extremely incomprehensible, to 5, extremely comprehensible. There was another measure assessing which statement they felt reflected the data best, but to save time we're going to skip it. Overlapping normal distributions were perceived most accurately, followed by bar graphs, followed by overlapping histograms. We see a similar pattern with comprehensibility ratings. Normal distributions were the easiest to understand, followed by bar graphs, followed by histograms. Study 3 was a replication and extension of Study 2, but this time with real data. The authors were interested in what effect different presentations of data might have on people's perceived similarity with an outgroup. For in-groups and out-groups, they chose to depict data for Brits and Poles. Each participant was randomly selected to view either overlapping normal distributions, bar plots with unrestricted y-axes, or bar plots with restricted y-axes. Data was taken from the European Values Survey, and each participant viewed the results for each of the 10 values simultaneously. After viewing the graphs, participants were asked to rate how similar the values of Brits and Poles are. How easily Brits and Poles can get along, which picture of overlapping circles best describes the relationship between Brits and Poles, and their overall evaluation of a Polish person. And now results. In these violin plots, we see that the participants rated Brits and Poles most similarly when they saw overlapping normal distributions, or bar plots with unrestricted y-axes. There was a similar pattern for getting along and the overlapping circle exercise, and again for overall evaluation of Poles, though in this last case, it was less dramatic. Study 4 was a replication of Study 3, but with a high school sample, and this time comparing a radar chart to 10 individual bar graphs with restricted y-axes. And again, we see overall greater perceived similarity between Brits and Poles in participants who were shown the radar chart compared with the bar graphs. For Study 5, the authors wanted to extend the findings of Study 4 to presentations of 2 widely disseminated and controversial studies. First, a meta-analysis examining IQ differences between religious and non-religious individuals, and second, a study examining the differences in moral foundations between conservatives and liberals. Participants were told they were going to view the results of 2 influential scientific studies and that they would be asked questions about the findings themselves and the quality of the science presented in the studies. For the religiosity and IQ meta-analysis, participants were randomized to see either restricted y-axis bar plots or overlapping normal distributions. For the conservatives versus liberals study, participants were randomized to see either line graphs, restricted y-axis bar plots, or overlapping normal distributions. After viewing the results of each study, participants were asked how similar the two groups were, whether the two groups would get along easily, whether the results make sense, their overall impression of the study, about the overall quality of the study, and the extent of bias they perceived in the study. And now results. The participants who saw overlapping normal distributions rated religious and non-religious people as more similar and more likely to get along. Overall quality of the research was perceived to be higher when shown the normal distributions, but the other measures of study quality did not yield consistent differences. And we see a similar pattern when looking at perceptions of the conservatives versus liberals study, except the line graph condition kept pace with the normal distribution condition. So in sum, the authors argue that if we want the general public to better understand our findings, we should seriously consider not using bar graphs with restricted y-axes at a minimum. They also argue for the use of perceived common responses and perceived common scores as potential things we can add to the list of statistics we put after each finding in our results sections. They felt that in doing so, we can better reflect the nature of our admittedly small differences and maybe even reduce the file drawer effect for null findings. Now, that is not to say that small differences are not meaningful. They certainly are. The authors argue that it is super interesting how even tiny differences in the values of citizens of a country can make up truly stark differences in, say, national policy. I have some reservations, though, on some of that point. Just because people say they believe in something does not mean they will act on it. To be fair, Hanel, Maio, and Manstead do say that question framing can significantly impact agreement among disparate groups. And I think this especially applies when viewing whether or not the downstream actions of people reflect the values they say they hold. As to how we report our results, I am definitely amenable to not restricting our y-axes, though I do worry this will make it harder to show some differences being larger than others, say, in an interaction. And I definitely believe we need to have more research looking at similarity. To me at least, groups not being different can be just as interesting as groups being different, especially if that similarity defies conventional wisdom. Looking to the future, I would like to see some specific measures developed to express similarity across more than two groups. I, personally, rarely do work solely comparing two groups, so it would be nice to have measures to express similarity across, for example, a factorial ANOVA, not to mention any of the crazy multi-level models that are becoming increasingly common in research today. Well, that's all for now. Please like, share, and subscribe, and if you've got a paper you'd like me to dissect, or more thoughts on this one, let me know in the comments.